Hey class, so today we're talking about objective 3 and 4 um, of chapter 6.5. So here we have an example problem that you'll see on your homework, and it says where does the terminal side of theta equals negative 10 pi lie? Give its corresponding coordinates, find sine of negative 10 pi. So like last time, we're going to start off by taking our coterminal um, coterminal angle formula to try to find its least non-negative coterminal angle. So we take negative 10 pi, we're going to add 2 pi k to that, and since we're not dealing with fractions, we can just see right away that this k has to be 5 in order for this to be positive. And when k is 5, we're going to get an angle of 0 radians. So what this tells us is that looking at our xy plane, 0 radians is along the positive x-axis right here. So that means that our answer is that negative 10 pi lies on the positive x-axis. Okay, so what do we mean by give its corresponding coordinates? So when we're dealing with these, we sometimes like to remember how we did r, x, and y last time? Well, it makes these problems a lot easier when we just set r equal to 1. So we're setting r, x, and y equal to 1, and therefore when it's on the x-axis, that means that it has moved 1 space to the right on the x-axis and 0 spaces on the y. So this is going to be 1, 0. Lastly, we want to find sine of negative 10 pi, and that is going to be taking the opposite over the hypotenuse. Remember, r is equal to 1. Opposite, though, is equal to y. So we're going to get sine of negative 10 pi is equal to our y coordinate over our r, which is 0, over 1, which is equal to 0. So here we have the axis on which it lies, the coordinates at which the terminal side is, or the point on the terminal side is, and we have evaluated sine of negative 10 pi. Okay, so here we have another example, but this time our angle is in degrees. Before we get started with this, I do want to make one small correction. In the last part of the video, I said we set r, x, and y to 1, but that's incorrect. We just set r equal to 1, so that whatever axis it's on, so if it's on the positive x-axis like it was last time, our y is going to be 0, which just means our x is going to be 1. So I just wanted to make that small correction. The only variable we're setting to 1 is r, and then we're solving for the other variable. So, okay, here we have 630 degrees. So we're going to start by using our coterminal angle formula to find where our least non-negative coterminal angle is. So we do 630 degrees minus 360 degrees times k. And this k is just going to be 1, because when we take 630 degrees minus 360, we get 270 degrees. So where is this on our xy plane? So we start with our positive x-axis, and we add 90 degrees. So this is our 90 on the positive y, 180 is our negative x, and 270 is going to be our negative y. So here it is. Okay, now we can write our coordinates, which is going to be 0x, and then it moved down on the y-axis 1, so minus 1. So remember, the way I got this minus 1 right here is from the Pythagorean theorem. So we just have r squared is equal to 1, which is equal to x squared plus y squared. And since it's on the y-axis, x is 0, y is equal to then positive or negative 1. And if it's on the positive y-axis, it's a positive 1. If it's on the negative axis, it's on a negative. It's a negative 1. Okay. So now that we have our coordinates, we can look at this function tan of 630 degrees. So tan is opposite over adjacent, but in our new coordinates, opposite is y and adjacent is x. So we're going to have tan of 630 degrees is equal to y over x, which is equal to negative 1 over 0. Now this is a problem, right? We have something being divided by 0. So our answer is that tan 630 degrees is undefined. And that's how you solve this example. Another way to quickly solve the last part of this problem, where it asks you to find tangent of 630 degrees, is to look at this table that you can find in your e-text. So this table labels all of the functions, trigonometric functions, sine, cosine, all of them, for each of the quadrantal angles. So you can see tangent of 3 pi over 2 is undefined. And remember, if you have something in degrees, like 630, or really it's going to be its coterminal angle, 270, you can transfer that to radians by doing pi over 180. So this tells us that 630 degrees is going to be the same in the same place as 3 pi over 2. So this is a quick and easy way to solve for any trig function for a quadrantal angle. Okay, so now on to objective 4. So objective 4 is understanding the signs of trigonometric functions. So what I've drawn out here is your xy plane and labeled the coordinates close to the origin. And these words that I've highlighted right here are telling you all of the things that are positive in this quadrant. So for example, in quadrant 1, all means all of the trig functions, sine, cosine, tangent, etc. Those are all positive in the first quadrant. Sine, this is just going to be sine, but it's also going to be cosecant. Because remember that cosecant is just the inverse of sine. And that goes on for tangent and cosine for quadrants 3 and 4. The way you can remember this is by saying that all students take calculus. So all students take calculus. And this is just a way of remembering which quadrant or which functions are positive in which quadrant. So let's look at an example and go through with that. Here we have an example, and it says let theta be an angle in standard position. Name the quadrant if cosine theta is greater than 0 and cosecant theta is less than 0. So this question is saying name the quadrant in which both of these conditions are met. So looking at our all students take calculus and seeing which quadrants cosine is greater than 0, we see that it satisfies the conditions in quadrant 1 and quadrant 4. So we can write down 1 and 4. We can do the same thing for cosecant, except now we're looking for the quadrants in which cosecant is not positive, where it's less than 0. So in this, we see that it is going to be 3 and 4. So cosecant is not positive in quadrants 3 and 4. Okay, and what we want is the quadrant in which both of these conditions are satisfied. So we can see that quadrant 4 is the only quadrant in which both of these conditions are. So the answer is quadrant 4. Okay, and then one more example should do it, and that'll be it for objective 3 and 4. In this example, we actually want to solve for a trig function with the information that we gain from knowing the signs in each quadrant. So here we have that tan theta is negative 1 over 2. So we want to look for the quadrants where tangent is negative. So the quadrants in which tangent are negative is going to be quadrant 2 and quadrant 4. We also want to see where cosecant is positive, and that's going to be in quadrant 2 and also quadrant 1. So we can see that quadrant 2 is the only place that is shared, or the only quadrant that's shared between these two conditions. And if we look at quadrant 2, remember that in this quadrant, you're going to have a negative value for your x's and a positive value for your y's, because you have to go to the left on the x-axis and up on the right on the y-axis in order to get into quadrant 2. That is important because we want to take tan theta and see that because it is equal to negative 1 over 2, we can see that our x should be negative and y should be positive. So it's actually supposed to be negative 2 right here. So then now that we have this, we can solve for r. So we get r as squared 1 squared plus 2 squared, negative 2 squared, which is going to be equal to the square root of 5. Okay, our definition of secant is r over x. So we have secant theta is equal to r over x, which tells us that secant theta is square root of 5 over negative 2. And that is our answer. So that's all for objective 4 and objective 3. Sorry if this video was a little bit long, but I wanted to get through a lot of examples. So hopefully this helps you.